Hi everyone, this class we will solve the problem 3 of the collection of problems about finite automata. In this problem 3, we are asked to describe the minimum deterministic of finite automaton that accepts all the words over the alphabet A and B that they have a odd number of A or a odd number of B's. So it is an oath that one of these conditions are satisfied, so our word is going to be valid, right? So imagine that I have the word A, B, A. So if we break down this word, this is going to be a valid word for the language, since we see that how many A's do we have here? Well, let's just see, we have this and this, so 2 A's. And how many B's? Well, we have only one B, so we have a total number of 1 occurrences of B, okay? Now, keep in mind that this number is an even number, and this number is not an even number. So, in terms of B, we have an odd number of B's, and then one of these conditions are satisfied, in particular this one. So this is going to be a valid word for this language, because I have an even number of B's, okay? Now, consider this word, for instance, A, A, A. So this is also a valid word because I have a odd number of A's, as we see. This is a odd number. And in terms of B, keep in mind that we have a even number of B's because the number of occurrences of B in here is 0, since we have no B's at all, then this is an even number. But it doesn't matter because this condition is satisfied, and it's a note that one of the two conditions are satisfied to verify that this word is a valid word for the language. Now, imagine that instead of AAA, I have the word BBBB. What happens with this word? Is this word a valid one for my language? Well, let's just see. How many B's I have here? I have a total of 4 B's. So this is a even number, right? How many A's? Well, I have no A's. Then the total number of A's is 0. And this is also an even number. Since both of the symbols, A and B, we have even number of occurrences, this word is not a valid word for this language. So this word doesn't belong to my language L, as we see, because both occurrences A and B, we have even numbers, right? Okay, so once we understand and comprehend deeply the language that we are working with, let's start with the construction of this automaton. So in order to build this automaton, we will work with 4 states, okay? We're going to have a state S that represents when we have an even number of A's and an even number of B's, up until what we have read from the input. Then we are going to have a state called A-O that represents that I have an odd number of A's and an even number of B's. The same, we are going to have the state BO that represents that I have an odd number of B's and an even number of A's, up until what I have read from the input until this moment. And finally, this state AO, BO that represents that I have both an odd number of A's and also an odd number of B's. Now, if we think about this, which of these 4 states is going to be the initial one, right? Which of these is going to be the initial state? Well, it is obvious that the initial state is going to be this one. Why? Well, imagine that I have this word, the word A, let's just consider the word A, B, B, A, okay? Imagine this word. Well, before reading any symbol from the input, I am here, I have read the empty word, and I am in the state S. Why? Because I have a total number of A's. 0 and the total number of B's, 0, because I haven't read anything yet, right? I haven't started reading the input. So since I have a 0 number of A's and a 0 number of B's, this means that since this is an even number and this is also an even number, I am in this state. When I have 0 number of A's and 0 number of B's, both are even numbers, so I am in the state S. Obvious, right? So this state S is going to be the initial state. Now, to represent that we have the initial state S, let's just build the state S like so. This is the state S. How do we represent that this is the initial one? Well, we just draw this error. This external arrow represents that this is the initial state in this automaton. Okay? Now, is this state, let's think about this. Is this state a final state? Which means if I end up reading the input and I end up in this state, will my word be a valid one for my language? Well, remind that my language accepts the words that I have a odd number of A's or a odd number of B's. So basically the state S is the opposite of this. Since I have an even number of A's and an even number of B's. In fact, the language L, we can rewrite this. This is the language L, right? The condition for L is basically that I have a odd number of A's or I have a odd number of B's. So if one of these two conditions is satisfied, then my word will belong to L, right? However, let's just consider the negation of this. If I negate all this, let's just negate these conditions, then the condition that we will have is the number of A's. The negation of is not an even number, then it's going to be it is an even number. Negation of the OR is going to be the end. And the negation of this is going to be also that the occurrences of B is even. And this is the negation of the condition to my word belong to the language L. So, and this is, in fact, the state S. Okay, this is what we are representing in the state S. So S is not a valid state. Okay. Since we know in the state S we have an even number of A's and an even number of B's. Okay. Let's now build the next state. Here I have the state A0, here I have the state B0, right? Or in this case for the odd is BO and AO. In this state AO I have a odd number of A's and even number of B's. And in this state, I have a odd number of B's and an even number of A's. And finally here, the state AOBO, where both A and B, we have odd occurrences of these two symbols. Okay. Now, what happens when I am in this state and I read from the input an A symbol? Well, since here I have an even number of A's and an even number of B's, when I read the A, I go from having even number of A's to having a number of A's. And in the same way, if I receive a B, I go from having even number of B's to having a odd number of B's. Okay, so this is the transition that we are representing in here. Okay, now before considering the transitions in the states AO and BO, because there are going to be transitions. Remember, in any deterministic or finite automaton, we have all the transitions defined. The transition function is a total function. Okay, so in the state S, I already covered the transitions when I receive an A or when I receive a B, or basically I read from the input the symbol A or the symbol B. Now, what happens if I am here in the state AO and I read an A? Well, if I am here, I have a odd number of A's. When I read the A, I come back to have a even number of A's. And in respect to B's, it doesn't matter. So because when I read an A, I don't change the number of B's in my word, right? So the idea to understand this is consider this word, the word AA. When I read the first symbol, at first I am in the state S because I haven't read anything. So when I read this, I go from here to here. And when I read the second one, then I have now again a even number of A's. So I go from here to here, right? So this is the idea of this transition. And the same goes for the B state, right? Imagine that I am in the state BO. I have a even number of A's and the odd number of B's, and then I read AB. Then I go again to the state S, since now I come back to have again a even number of B's. Now consider, I am in the state AO, okay, and I receive AB. Well, in the state AO, remember, I am having a odd number of A's and a even number of B's. What happens when I read AB? Then I go from having a even number of B's to have a odd number of B's. So then I come here. This is my transition. When I receive a B, I go to this state. Since here I have odd number of A's, but even number of B's, when I read this B, I go to have odd number of B's, and I keep and I maintain the same number of A's, which is odd, since I don't change this number, unless I read AA. But this is not the case because I'm reading AB. Yes? Now, with this we covered the transitions for AO. Now we have to cover the transitions for BO. I already covered when I receive AB. What happens when I receive an A? Well, when I receive an A, I am in the state here where I have a even number of A's, okay, and a odd number of B's. So when I read an A, I come here. And here, I go from having a even number of A's to have a odd number of A's, right? So now we have covered the transitions for A0 and, in this case, AO and BO, right? And before coming to these transitions in this state AO-BO, let's just ask the student. Student, do these both states, the state AO and BO, are those states final states? Consider, are they final state? Well, to know this, we have to remember the condition of this problem. The condition says either I have a odd number of A's or I have a odd number of B's. Now, take a look at this. In this state, I have a odd number of A's, so one of them is fulfilled. Although I have an even number of B's, it doesn't matter because one of the conditions is fulfilled. So this is a valid state, a final state also called. And in here, in the state BO, okay, what I verify is the conditions that I have a even number of A's, but I have an odd number of B's. So one of them is also verified, right? So this is also a final state, okay? Now, let's come here. In this state, I have a odd number of B's and a odd number of A's. What happens in here if I read a B? Then I go from having odd number of B's to have a even number of B's. And in respect to A, I maintain the same. I have odd number of A's. So now I have to come here, in which I have a even number of B's and the odd number of A's. And now, again, when I read an A, I go from having odd number of A's to have a even number of A's. So I have to come here, where I have even number of A's. Okay, in respect to B, it doesn't change at all because now here I have a odd number of B's. I read an A, I have an odd number of B's as well. Yes? And finally, before finishing this problem, is this state a final one? Well, here I have that the state EO, BO, and AO is the one that we have a odd number of A's and a odd number of B's. So now, if I remember the condition for this problem, both of them are verified. Okay, remember that the condition, either one or the other, okay, it is an oath. But now here I have the both of them. Perfect, this state is a valid one, is an accepted state. Yes, because both of them are satisfied. It's an oath, it would be an oath that one of them, okay, to be a final state, but here, well, I have that both of them are satisfied. So this state is also a final state for this automaton. So this is the final automaton for this problem 3. I remember the student that he can check the statement of this problem as well as the solution in the resources of this class.